Our first example here reads, during a race on level ground, Andra runs with an average velocity of 6.02 meters per second to the east. What is Andra's displacement after 137 seconds? 137 seconds is a very odd way to talk about time, but I guess if we're wanting that instead of if we want seconds instead of hours, that's a good way to put it. So we know we're a little over 2 hours, basically, is what the problem's saying. So we run with an average velocity. So I'm going to say V cap. Remember, V cap is your average velocity. Average happens right in the middle. Now, if we're moving at a constant velocity, our average velocity equals the velocity at every single point. So we're moving with an average of 6.02 meters per second to the east. Remember, this direction is important. If we don't include direction, then we only have a speed, not a velocity. And we know our time is 137 seconds. So to find our unknown, which is displacement. Displacement, remember, is given as delta x. That's what I'm trying to find. So we need to rearrange our equation a little bit. Our equation for average velocity is average velocity equals delta x over delta t, or in some cases I'll write that just as t. But we need to rearrange this to be able to solve for delta x. So that means I have to get delta t on the other side. Now, because this is division, I have to multiply on both sides. So I'm going to do that here, times delta t. Now, when delta t is multiplied by 1 over delta t, those cancel. Okay, that equals 1. So we're left with delta x equals our average velocity times our time. Now this problem is pretty simple. I just multiplied those two together. My average velocity, 6.02. Now in our calculations, we can't show that, we can't show direction through our calculations, so we just have to look at that in the end. So 6.02 meters per second times 137 seconds. Our seconds cancel. So delta x equals 825 meters. Now delta x is a displacement, so I'm going to be sure to include the direction east. Alright, pretty simple.